So welcome to physics, and our first topic for the year is electrical charge. So by the end of this lesson you should be able to do the following 1, 2, 3, 4, 5, 6, 7 things. Okay, so if you by the end of the lesson you still cannot do these 7 things, or for example identify common materials, describing experiments, then you need to either come and see me or get some help from your colleagues, so we can all make sure that everyone gets the same outcome. Everyone should be able to know these things. Okay, so let's first look at electrical conductors and insulators. Okay, so an electrical conductor is a material through which electricity current flows easily. So examples can be, for example, copper wire. And the reason why copper wire is a very good conductor of electricity is because it is a metal, and all metals are known to conduct electricity. Okay, so if there's a lightning storm outside, you don't stand there with a giant copper wire on your head, because you're going to get electrocuted. And on the other side we have something called electrical insulators, which have very high resistance to the flow of electrical current. Example of that would be the plastic that goes around wires to make sure that if you touch it, you don't get electrocuted. Okay, so what I want you to do now is to pause the video and complete the table below. So as you go down, listing them either the objects as either conductors or insulators. Okay, so pause the video and then we'll come back and see if you've got them all correct. Okay, so welcome back. So copper, we've already said in terms of copper wires, is a conductor. Okay, is rubber a conductor or an insulator? You should have had it as an insulator. Okay, it actually stops electrical current going through it. Steel is a metal, so it will be a conductor. Mercury is also a metal, the only liquid metal, and it's also a conductor. Paper insulates. Plastic also insulates. Diamond is a insulator as well, and graphite is a conductor. A little trick there, okay? Even though it's non-metal, graphite indeed conducts. Okay, so the graphite in your pencil does conduct. So let's now look at electric charge. So electric charge can either be positive or it can be negative. And a bit of chemistry here. I'm sorry, I'm a chemistry teacher first and foremost. In an atom, an electron has a negative charge that is the same size as the positive charge of the proton. So that means in atoms, the charges cancel out. Number of protons will equal the number of electrons. Number of positive charges will equal the number of negative charges. Neutrons in the middle and the nucleus have no electric charge. So as an atom has the same number of electrons as protons, it is unchanged. Okay, so in terms of static and current electricity, so we'll look at static first and we'll then move on to current electricity. Static electricity describes a situation where the electric charges remain in the same place. They are stationary. That's what stationary means. Whereas, and this occurs best with insulators. Okay, so most of the charge stays in the insulators. Whereas electrical currents are involved when electric currents or charges start moving from one place to another. That's why we're saying there's currents going through a metal wire, because the electric charges are moving in that wire from one end to the other. And this occurs best in conductors, like metal wires. So you can charge materials using friction. So when certain insulating materials are rubbed against each other, they become electrically charged. Because what's happening is the electrons on the surface of the material, of the insulator, are being rubbed off from one material onto the other. So one material is gaining electrons or gaining negative charge to become overall negatively charged, and the material that's losing this negative charge is then got positive charge in an equal amount. So here's an example here. If you have a dry cloth of, say, wool, and you rub it along the perspex rod, then the electrons are going to be pulled off the perspex rod, the cloth becomes negative, and the perspex rod becomes positive. Okay, so now we have unequal charges on the insulators. So we're going to have something called forces beginning to interact. And there's a strong link between force and charge. So when you have a charged object being brought close to an uncharged one, two objects will attract each other. Okay, here's an example here. A charged comb will attract a column of water. Okay, the water itself is neutrally charged. Okay, number of electrons equals number of protons, number of negative charges equals the number of positive charges, and it's going to be attracted by the charged comb. And another example would be the charged balloon attracted to a wall. Okay, so there's two forces operating here, the forces of attraction and repulsion. So if two bodies or objects carry different types of charges, they will attract. Okay, so if you have an object which is positively charged, it's going to be attracted to an object which is negatively charged, and vice versa. And if you have two bodies or objects that carry the same type of charge, they're going to repel. Okay, so a positively charged comb is going to be repelled by a positively charged comb, and conversely, or vice versa, a negatively charged comb is going to be repelled by a negatively charged comb. Okay, so the laws of charges are that like charges repel and unlike charges attract. Okay, so it seems in this particular picture, the boys here seems to be all the same type of charge. And here's just an example here. If you have a perspex rod which is positively charged and a positively charged perspex rod is pushed against it, they're going to repel, so therefore it's going to rotate. And conversely, if you have a positively charged, that's the first example here, and conversely, if you have a positively charged perspex rod and a negatively charged rod is brought close together, it's going to attract and pull itself towards it. So let's now, in summary, choose appropriate words to fill in the gaps below. Okay, so I've actually given you the word selection that I'd like you to use. So looking at the words that are at the bottom of the video, just choose the correct word for the correct gap. So pause the video now, and when you think you've got the answers, unpause and let's see if you've got 100%. Okay, so let's begin. Static electricity occurs when electric charge remains stationary on an object. An insulating object can be charged by rubbing it with another insulator. One of them gains electrons and becomes negatively charged. The other becomes equally positively charged. And finally, the law of charges states that like charges repel and unlike charges attract. Okay, so that's the first part of the lesson around charges. So what are some practical problems that happen because you've got static electricity? Okay. So when an oil or petrol is pumped along pipes, a static charge can build up on the pipe, which can result in a spark. Sparks and fuel don't go well together. They tend to have explosions. Okay? Because the fuel vapor reacts with oxygen in the air and has a combustion reaction. Okay? So there we have it. Usually we have the fuel pipe is connected to the earth, so that means that the static electricity goes down through this earthing circuit down to the earth, and so it doesn't cause sparks, which would be a bad thing. Anti-static floors in hospitals. Okay, so in operating theatres it's important that the doctors don't get charged when they're walking around the room, okay, because then they can zap things. We don't want that. And also because of the gases they use to put you to sleep can be explosive. And again, spark, explosive gases, not good. Okay, so what they do is they have anti-static material on the floor surface, so charge is not conducted into the shoes of the doctor, it's instead conducted down into the earth. Also, some of the useful applications of static electricity, not just the negative, is paint spraying. So the spray nozzle, as you can see from the image, is connected to a positive terminal on an electrostatic generator. As the paint droplets leave, they repel each other and spread out to form a fine cloud of paint. And the metal paint is then painted. To be painted is connected to a negative terminal. Okay, so positive, negative, you've got that attraction, which means that the negatively charged metal plate attracts the paint which is being taken out of the nozzle of the spray gun. Very important for us teachers, inkjet printing. Okay, there's a diagram there also illustrating what happens above. So you've got little spots of ink and they have a small amount of charge, and as they leave the ink nozzle in the machine, and there's deflecting plates in the printer, and it causes the drops to hit the right part of the paper at the right time and deposit. Okay, these charges on the deflecting plates then change many times per second, so each drop hits the paper in different positions. Photocopiers, again, important for teachers. So you've basically got a photocopying drum, okay, which is conducting, is a positive charge, until light falls on it. Okay, so that means that when the light is reflected off the paper onto the drum, the areas of black do not reflect, so the charge drum remains positive, whereas it is now neutrally charged, where there's actually going to be an image. Okay, and what happens is you've got this black toner sticks to the drum where it's still charged, only where it's positive, and it presses onto the paper. That means that the paper is finally heated to stick the toner onto it permanently, and that's how you get your image on the piece of paper. Yeah. So then we also have the smoke precipitator. So you've got these metal plates which are charged opposite to the grid wires in the middle, in the chimneys of industry. Okay, so you've got these waste gases coming up, carrying all the ash and dust. We don't want those in the air, causes pollution. So what happens is the ash and dust then collects on these plates. Okay, because you don't want entering the dust entering the atmosphere. Okay, the ash and dust become charged as it passes through the charged grid of wires, and then can be collected on these metal plates. Okay. And when the plates are shaken, the accumulated ash and dust falls down to be collected and to be removed. Okay, there's just a few online simulations which you could possibly look up to kind of reinforce what we've done in class.